Anyway, don't take root of any imaginary number. Say bi. Hi guys, welcome to this channel. I'm your 24-hour math tutor. I'm excited to shoot this second video for a math exam question. I think complex number is like an island of algebra because in high school level, this topic will neither lead you to many theories nor closely related to other algebraic topics, right? Take a look at this question from IB high level math. First, it is given that z raised to the power 4 equal to a negative number, and z belongs to a complex number set. Put aside part B. A is asking you to solve the equation A plus IB, where A and B are elements in real number set. Seems that this kind of question or this kind of equation may entice you to use polar representation of complex number. Yes, theoretically you may use this to solve it, but it's time consuming to convert the solution from polar representation back to the format A plus IB unless you are extremely proficient in manipulating polar representation, right? If you want to try this question on your own, please pause this video and come back after you've finished. First, let z equal to a plus ib or bi, it doesn't matter. Then we may take the square root of negative 4. Then we have z plus or minus 2i. Because 2i is an imaginary unit, taking square root of it requires some techniques. One is to expanding the square of a plus ib and comparing the real and imaginary parts. Case 1 is to consider positive 2i only, and by comparing real and imaginary parts, we get a to the square 2 minus b squared equal to 0 and 2ab equal to 2. After solving these two equations, we have a equal to b equal to 1 or a equal to b equal to negative 1. Now, case 2 is to consider negative 2i only. Similarly, by comparing real and imaginary parts, we have a equal to 1, b equal to negative 1, or a equal to negative 1, b equal to 1. Combining case 1 and 2, the roots are 1 plus or minus I and negative 1 plus or minus I. There are 4 roots. Now, part B actually requires you to know several things. First, as the complex number is raised to the power 4, there must be 4 roots. Of course, some of them may be equal roots. Therefore, the number of vertices representing the roots in the complex plane must be less than or equal to 4. Now, let's have the complex plane. The horizontal line is the real part, and the vertical one, as you know, should be the imaginary part. Now the 4 roots are 1 plus I and then 1 minus I. Similarly, negative 1 plus I and negative 1 minus I. So this is actually a square with the side equal to each side equal to 2 units. Okay, so the second part is that the polygon is a square with base 2 and height 2, so the area is 4 square units. Let's recap some of the techniques and basics of complex numbers. First, we have I squared equal to -1, and that's the only definition. Some books saying that I equal to square root of -1, but some books saying that it is not good. Now, if I have time, I will explain why some books saying that I equal to square root of -1 is not good. Anyway, don't take root of any imaginary number, say bi. Finally, we have a very important technique to solving this kind of problem. That is comparing real and imaginary parts. The explanation for this technique is that when you move all the numbers from the right to the left and making this number equal to 0, then both the real part and imaginary part must be equal to 0 and vice versa. So that's the reason we come to the same conclusion that a squared minus b squared equal to x and 2ab equal to y. That's all for this video. If you like this one, don't forget to give me a thumbs up and subscribe and share. Hope you enjoyed. See you in my next video.